in this second example, they say for each of the identities, first say what's the non-permissible values, and then actually prove them. We're going to prove them first, and after we've proved them, it's easier to see non-permissible values afterwards. Non-permissible values, what are we not allowed to do in math? Can't square root negatives. These questions have no square roots, so we don't have to worry about that. But you can't divide by 0. So one of the things we're going to do is, after we've proven it, we're going to look at all the places in the proof where you're dividing, and we have to make sure that nowhere do we divide by 0. So let's look at the proof first. How do we set up our proof? We rewrite it and we draw a line. This one is a classic, and you change things to sine and cos. Okay, so the right-hand side is already cos. I'm going to leave that. For the left-hand side, here's my main fraction line. The top is cotangent. Cotangent is cos theta divided by sine theta. Cosecant is 1 divided by sine theta. Okay? Now I have a fraction divided by a fraction. The rule for a fraction divided by fraction is to multiply by the reciprocal. Sine theta to simplify. And we're done our proof. As far as now that we've done our proof, for non-permissible values, take out a highlighter and highlight all the places in this question that you're dividing. Technically, we're dividing by 1 here, but I don't need to highlight a 1 because 1 is never equal to 0. And we have to figure out where are these things equal to 0. If you have reciprocal functions like the cosecant, you would switch them to sine anyways. So it is enough, if you change things to sine and cos, it's enough to look through this question and find out where you have sine and cos on the bottom. And in this case, do you see that the only one of those that we have on the bottom is sine? So for our non-permissible values, we know that sine of theta can't equal 0. Then we go to our unit circle. Sine is which coordinate? Your y coordinate. Where is sine equal to 0? 0, pi, and 2 pi. And 3 pi, and 4 pi, and 5 pi, and 6 pi, and 7 pi, and 8 pi, and so on. So, from chapter 6, the zeros of sine are k pi, where k is an integer. So we put a line through there saying that those are the non-permissible values. Theta can't equal all the multiples of pi. Sometimes it's easier to figure out those non-permissible values after you've done the proof. And again, this proof is a great example of where we change it to sine and cos, we use our fraction rules and simplify. Things worked out beautifully. Part B. Again, rewrite the equation, split it up. And again, I look at this one, and on this side, I would decide to change the secant to 1 over cos. Now, same as before, now we have fractions inside of fractions. Our goal then is to get a single fraction in our numerator, a single fraction in our denominator. So sometimes I really make a point of making the main fraction line thicker or longer. Can you see that the top you could make as a single fraction if you made it over 1? So top was easy to get as a single fraction. For our numerator, for our denominator on the bottom, I'm going to have to multiply this 1 by cos theta over cos theta to get a common denominator. And then the bottom would be a single fraction as cos theta plus 1 over cos. So I use my fraction rules to get a single fraction in my numerator, single fraction in my denominator, and now fraction over a fraction. Oh, work's already done for me. I can multiply by the reciprocal, so that means I rewrite the first one. I take the second one and I flip it, and I notice that the cos theta plus 1 is an identical factor, so it can cancel out. Okay? When I talk about identical factors, it's really important that anytime things are added or subtracted, they get grouped together. Here's a common mistake. Just do it off to the side. Don't write this down, but off to the side in purple, I sometimes have this, and I see students wanting to do this. This is not allowed, because we can only simplify when we have factors that are identical, and if we're multiplying. Now, technically, I'm going to remove those red lines. Technically, on the top, we have cos theta plus 1. This groups this together as one factor. And the only way you can cancel something in that is if you would have the identical factor on the bottom. But on the bottom, you just have cos theta. It would need to have a cos theta plus 1 on the bottom to simplify that. But it is so, I guarantee, this is like, mathematics is like chocolate, it's tempting. You'll be like, ooh, I'm tempted to cancel that out. You're not allowed to in this situation, because you can only simplify if factors are identical and if you're multiplying. So here, this cos theta plus 1 gets grouped together, this cos theta plus 1 gets grouped together. We're multiplying, those factors are identical, so we are able to simplify those. And as a result, we just get cos theta, so that's identical to the left side. We're done. Looking through this one with our highlighter. Now we'll do the non-permissible values. Where are we dividing? Okay. So I went through the whole thing and highlighted all of my numerators. So for my non-permissible values here, I know that cos of theta can't equal 0. I also know that cos of theta plus 1 can't equal 0. So we need to write out all of our zeros of cos of theta. And I don't know which form you remember the best, but maybe odd numbers of pi over 2. So theta can't equal 2k plus 1. And if you look at this one, where is cos theta equal to -1 on your pi plate? That is just at pi. So theta also can equal pi, and you have to write the general solution for that. Those would be all of the non-permissible values in this question. So we have a bit of general solution going on here, a little bit of coterminal angles and zeros. So all of those concepts that we've done in the past are coming together in the non-permissible values. But more importantly is, can you prove this? come up with the proof. So I'd like you to circle 4, 8II, 9II. And we're going to leave example 3 for later.